All right, in order to find the equation of a tangent line to an implicitly defined equation, where it specifies what quadrant we need this tangent line to exist, there's several phases to this question. First, before we begin, just realize that if they ask you for a tangent line, don't forget that this is the way that we need to figure out this question in order to set up the actual answer. Now, because there's so many different parts of this question, here's what I'm going to suggest. To begin, let's first find the point on the graph that we'll be using for our tangent line. So, since they tell us that the x value is going to equal 1 in this case, let's take 5x squared minus 2xy plus y squared equals 13, and let's figure out what the y value needs to be. So, we know the x value is 1, so let's plug in 1 into this equation. We'll get 5 minus 2y plus y squared equals 13. Now, when you see the nature of this equation, it is quadratic. So in order to solve for y, it's helpful to write this as y squared minus 2y, and if you subtract 13 from each side here, notice you'll end up getting a minus 8 equaling 0. Why would we set this quadratic equal to 0? Well, that's generally the easiest way to solve a quadratic when it's factorable. So in this case, we'll get y and y. We'll get a plus and a minus, and if you factor correctly, you should be able to get a y plus 2 and a y minus 4. So notice our two answers for y are either negative 2 or positive 4. What this means is that there's actually 2 points on this curve that would satisfy this equation. 1, negative 2, or 1, comma 4. So if you got a question that said use the first quadrant, then we'll go ahead and use the point 1, 4. If you got a question that said use the fourth quadrant, then we'll use the point 1, negative 2. So let's leave that for a moment now and get to our slope calculation. In order to find the slope, we need to find the derivative of this equation. So notice since we have an implicitly defined equation, we need to use the process called implicit differentiation. This is going to involve taking the derivative of both sides of the equation to give us 10x minus, and now here is probably the most tricky part of the entire problem. This term, minus 2xy, causes a lot of problems for people. xy requires the product rule, but negative 2 is our constant multiple. So negative 2 is going to be on the outside, and then we're going to take x times dy dx plus y times 1, or in other words, just y. Then we'll take plus 2y dy dx for our plus y squared, and this is all going to equal the derivative of 13, which is 0. So notice what we have to do now. In order to get this answer correct, make sure this negative 2 properly distributes to both of those terms. So that's going to give us 10x minus 2x dy dx minus 2y plus 2y dy dx equaling 0. So if you remember how to solve for dy dx now, we have to do a little bit of sorting. Let's keep the negative 2x dy dx and the plus 2y dy dx on the left. Let's actually move the negative 2y over to become a positive 2y, and let's move the 10x over by making it a negative 10x. Now, in order to solve for dy dx, let's factor that out, leaving a negative 2x plus 2y equaling the same thing on the right. And then dy dx is going to be equal to a 2y minus 10x. And then for the denominator, I'm going to switch the order of these terms so that it says 2y minus 2x. Now, please do not oversimplify this derivative, because if you guys try canceling out the two y's, or if you try canceling out the x's, that's algebraically incorrect. So the only thing I would actually do to simplify, if you want to, is to factor out a 2, since all of these terms are even, and get y minus 5x over y minus x. This is the derivative, which tells us all the slopes on our graph. So, since we have 2 points to deal with, depending on what quadrant you're in, let's start with the first quadrant answer. The first quadrant gave us the point 1, 4. So let me switch over here to green. And if we want to use the point 1, 4 in our equation, well, let's find the slope at the value 1, 4. So in order to plug this in, all I'm going to do is plug in a 4 anytime I see a y, and plug in a 1 anytime I see an x, and calculate. This is going to give us 4 minus 5 over 4 minus 1. Pretty easy calculation to get a negative 1/3 for our slope. So for our first answer in the first quadrant, we can take y minus 4 equals negative 1/3 x minus 1. So in the first quadrant, our answer for our tangent line would be y equals negative 1/3 quantity x minus 1 plus 4. Now, if we're going to do the same problem, but now at a different point, let's use the fourth quadrant answer and use the point 1 comma negative 2. This involves finding a new slope. So dy dx at the point 1 comma negative 2 is going to involve pretty much the same calculation, except now a negative 2 gets plugged in for y, minus still a 1 for x, and that's going to give us negative 2 minus 1 in our denominator. This answer is going to be a negative 7 over negative 3, or a positive 7/3 for our slope of this line. So using 7/3 as our slope and using 1, negative 2 as our point, we could take y plus 2 equals 7/3 x minus 1, which means in the fourth quadrant, our tangent line can be written as y equals 7/3 x minus 1 minus 2. Our two answers for this question depends on which quadrant you were asked. If you get asked for the first quadrant, our answer is right here. If you get asked for the fourth quadrant, our answer is here. Make sure you take a look at what the problem asks for and solve accordingly.